Our next speaker is Ilka Klaas, who is an associate professor in the University of Copenhagen in production diseases, and she works mainly in the area of mastitis. And her talk is entitled Potentials and Challenges for Diagnosis of Contagious Other Pathogens with Real-Time PCR Tests from Samples at Milk Recording. So over to you.
Yes, thank you very much, Mr. Chairman, and hello everybody. Now we're moving to another species again, to the cows. And I would like to talk about the potentials and the challenges of PCR tests taking at milk recording. We have, after all, some experience with these samples because they are quite popular, getting more and more popular in Denmark. And next. Okay. Since 2010, the pathoproof test was offered and more farmers adopted. And one reason it was very popular is that we have some legislation that says that we have to test all the cows before dry-off with a diagnostic test before we are allowed to use dry cow antibiotics. So that was, the test was approved for that, and this is one of the main reasons. Also, when there were whole herd investigations, it was quite popular, and since 2010, we do also the annual bulk tank milk surveillance program for B streptococci with this test. So why would we use it? For the farmers, it was so easy. They could order it with their computer. They were automatically taken, then at milk recording, they would automatically receive the results. That was easy and it's very nicely done. They knew it is a very high sensitive test. Typically you will receive the results as the CT value, and the cutoff to divide between infected and non-infected is with this test 37, with 40 as the maximum CT value, where you would say this cow is definitely negative. And the lower the CT value, the higher the amount of the DNA in your sample. So the farmer would also get information about how bad is it or how heavily is the cow shedding bacteria. So everything's fine. Not really. When we thought more about it, what about the contamination or the risk of carryover between cows? Most of those farmers, they have just their usual routine. They do not do any kind of teat disinfection, and cows are not ordered according to their infectious status. So that could be a real risk of spreading bacteria around and getting false positive samples, test results. So therefore our research questions, they were, well, what is the sensitivity and the specificity if we move these PCR tests and use it on milk recording samples? And also, do we have any kind of effect how we treat the cows before testing them on the results? And of course, we wanted to know what happens with the between-cow carryover for Streptococcus galactea and Staph aureus. We had a study where we followed 6 herds. We selected them based on the bulk tank CT value, and we repeated that. We did that repeatedly to make sure that there really was something, some infections going on. And then we came on one milk recording day where all cows were sampled with a PCR test, and we selected some cows, approximately 50%, for culturing. And as we did on aseptically taken samples, and if we were in a rotary parlor, we simply choose every other cow and every other milking unit and tested each cow at this milking unit. And if we had a side-by-side or a herringbone parlor, we used on one side all the even milking unit numbers and on the other side all the odd numbers. And after the milking, we retrieved the data from the milk meters to analyze for the carryover effects. We also looked what happens with the dry cow samples. There we chose 7 herds, and 3 of them had a milking robot, which meant we could not run after specifically the same milking where the test was taken. But in this case, it was within 24 hours where the milk recording took place. And here again, a PCR test versus aseptically taking 4 mix samples, and then we defined a positive cow is for us a cow that has at least one colony-forming unit in at least 1 quarter. If we first have a look what happens with Streptococcus agalactiae, we not only wanted to know what is sensitivity and specificity at the defined cutoff, we also wanted to know what happens if we change this cutoff. And to analyze that, we used the latent Klaas analysis, and this is a modeling where you don't need to have a gold standard, and which is modeling telling something about the underlying disease you are measuring. If you start looking at the specificity for both the PCR test and the culturing, not that much is happening regardless of the cutoff value you choose. And they are both very high. But if we look at sensitivities, then we see that suddenly that the CT value cutoff for PCR not only changes the sensitivity, which we estimated, it also changes the sensitivity of culturing. And basically, it looks like the higher the CT value threshold, the higher the sensitivity of the PCR and the lower the sensitivity of culture. And if you go down to the lower CT value thresholds, we see that both tests perform in the same way. There was no significant difference between them. And that could also indicate something of the characteristics that you have a very low amount of bacteria here. And if you have the higher cutoff, and you have a very much higher amount of bacteria here. So probably if we have a lower cutoff, our underlying disease definition is a more heavily infected cow, whereas here, if we choose a high cutoff, it's more a cow that is positive. And we see the same pattern if we look at Staph aureus. The differences between the sensitivities for culture and PCR, they're not as large in comparison to Streptococcus agalactiae, but we have the same tendency. The higher the CT value threshold for Staph aureus, the lower the sensitivity for bacteriology. So we should think about which kind of threshold do we want to choose when we want to interpret samples from PCR tests taken at milk recording. And until now, it looks like, well, very sensitive test, looks very nicely, especially for Streptococcus agalactiae, performs much better than the bacteriology that we used. Well, yeah, there was still this issue about carryover and about preparation of the cow. And the short answer is there is an influence. We could see that clearly with Staph aureus. In those cows where we took the milk samples, where we disinfected the teats and where we took the quarter milk sample, there we could clearly see that we have a reduction in the odds of being positive in the PCR test. And that gives me a strong indication that we should work very hygienically when we take these samples, because there could be an issue with contamination. We also looked at the milking order. And here we have an effect. We looked at it and we said we want to know the correlation between cows milked at the same milking unit. We used an autoregressive correlation structure, which means that cows milked closer together are more correlated than cows milked further apart. And the correlation was 13, 11, and 9%. And here again, we see the effect of choosing a cutoff. We cannot remove the carryover, which is there, no matter what we do, but we can do something about the magnitude of the correlation. But then we could also think, okay, if I use a lower threshold, then I might also lose some of the cows that were truly infected, but just only with a tiny amount of bacteria. And then we did a little bit of a different approach. We said, okay, if we divide our cows into several classes, 5 classes of CT values, and we have a look, how does the class a cow is in affect the probability of the next cow to be in a certain class? It looks quite complicated, and this is why I think it's the most important thing to look at the green line and ignore a bit of the others, because what we see is that if a cow is negative in Klaas with the CT value 40. The next cow in the same unit has a 60% probability of being negative as well. But if we do have the previous cow, if this cow is shedding less than CT value 31, the next cow would only have a lower than 20% chance of being negative. And that is also a kind of a strong indication that we have problems with carryover. And this is a factor that was constant as we looked at certain herd effects, but this was a pattern we could see in all the herds and with all the typical candidates we corrected the data for. So again, we should be very careful when we use this data. And here I agree with Mara Freeman. She said this morning that we should be very careful when we interpret these results. And I would like to add, especially if they come from milk recording, and also think about why would I choose a high or a low threshold? What can I use this for? Sometimes you may be interested to identify as many positive cows in the herd as possible. But still, we need more information about the high CT value cows which we cannot culture. What does that mean in a biological way? Is that a problem? On the other hand, if we choose a lower CT value, yeah, well, then we are getting closer to the performance of the culture. So you could say, why not use culture then instead? T-disinfection we talked about before. Then we have this issue of handling somehow the contamination and the carryover. If you have a herd with a low prevalence, then it's not that many cows that would look suspicious where you would take another test. But in some herds where you have high prevalence of cows infected with B streptococci, you might find them in nearly every milking unit in a way. So what we basically do, we use them aseptically taken from examples, and we try really to avoid contamination as much as possible. For example, we change the gloves. And if you also think about the dry cow samples, there you don't have any kind of a chance to know what the status of the cow before was. So it's quite a gambling to know if the DNA is from the cow you have in mind or not. And thank you very much for your attention.
Thank you very much, Ilka. Anyone with any questions, could you make your way to a microphone? Is this technology in practical use yet in Denmark, or is it still at a development stage?
Well, it's used. I don't know the numbers of 2015, but it were approximately 70,000 samples taken in 2014. So it's quite in use, yes.
Yes.
I was just wondering if you looked at any differences between parlours where there was a back flushing unit or ADF. We have quite a few in the UK where they have peracetic acid flushed through the unit after milking, and I wondered if that would improve the specificity of the test.
That could be a good idea to do. We haven't done this with these herds we have investigated so far.
Anyone else? Okay, thank you very much.
Thank you.